All right, we've all heard the expression, one thing leads to another. Mathematicians, when they think about that concept, have a name for that, and it's called a relation, that one thing is related to another thing that seems to describe just about everything that goes on around us. So we're going to explore the mathematical ideas behind this concept of one thing leads to another. And there's a couple of different types of situations. So one of them, for example, is what you experience at the gas pump, where you choose a particular grade of gasoline at the particular place that you're pumping the gas. And as you input gas into your vehicle, you get an output from that in dollars. So there's that relationship of the number of gallons of gas that you pump to the number of dollars that leave your wallet in order to pay for that. Okay, on the other end of that, you have input gasoline into your car, and your car is going to output some energy that moves it down the road, so there's a relationship in there as well. Okay, but in the case of the gas, if you pump 10 gallons and it's running at $3 a gallon, then you're going to pay $30 for that particular fill up. Okay. Another type of relation, okay, one thing leading to another. If we looked at running a red light, okay, running a red light might not lead to anything. It might just lead to you getting to your destination before you were planning on it, because you ran the red light. It might lead to a ticket. If you ran the red light and there was an officer in the area, or if it was a video monitored intersection, then you might end up with a ticket from that. So running the red light leads to a monetary penalty. It might lead to nothing. It might lead, in the worst case, to an accident and a variety of different things there. In this case, our one thing leads to another. We can't really define clearly what that other thing is going to be the way that we could with the gas pump. Okay? Both of these situations are referred to by mathematicians as relations, but the first one is one that we focus a lot of attention on, and we call that one a function. So a function is one of these things where an input leads to an output, but every input that we use has only one possible output. Okay, so at the gas pump, because we know how much gas we pumped and it had a fixed price, we know exactly what the output is going to be. There's no question about that. In the running the red light, we don't know what the output or the outcome is going to be in that case. So if we were talking about a function, okay, this particular name, the input has only one possible output, and there accompanies that a very clear set of instructions on how we are going to change inputs into outputs. Okay, in the case of the gas pump, the input is the number of gallons of gas that you pumped, and the clear instructions are multiply that by the price per gallon of gas, and you will come up with how much you owe for the gas that you pumped. All right, let's get into the details of functions here. Okay, that definition, again, there is a notation that goes along with this in mathematics. Okay? And the notation I separate kind of into three different parts. First of all, a name is given to a function. Okay, we can use lots of different things. We might call the function f. We can call the function g. Those are very common ones. We can give them more descriptive names. We could call the function Carl if we wanted to. Okay, but a function has to have a name. The next thing that happens is we get a variable identified with our function. So the variable okay, sorry about that, I lost track of my notes a little bit. Our variable can be anything in there, so we might talk about f of And maybe we'll use the variable x with this one. Okay? And you heard how I read that. I'm going to go over that again here in a little bit as well. We might talk about g of, and maybe we could use the variable t. Okay? So we pick some variable to use in there. And for our last one, let's go with Carl of, and I'll put a y in that one. Okay? So we assign a variable, and this is how we assign the variable to it. We put it in parentheses after the name of the function. And again, I read this first one as f of x. This is g of t and Carl of y. It's important to note in this notation that this does not mean f times x or g times t or Carl times y. Those are, that would imply multiplication in this case. The parentheses, because we are talking about functions, is not talking about multiplication. That's a very important thing to keep clear on this. So again, we'll read this one as f of x or g of t or Carl of y. So the function has a name. We identify a variable that goes along with that name, and then we have a rule to define how to change the inputs into the outputs. Okay? And so in this one, we'll make up some rules here. We'll say that our f of x, the rule for that is, I'm just going to say 20x plus 8. So the variable, it says the variable in the rule that you're going to see is an x, and this tells you what to do to that x. It says multiply by 20 and then add 8. Okay. Our g of t, say our rule for g of t is going to be negative 16 t squared plus 20t plus 6. Okay. And let's, so the rule, again, based on the variable t, it says whatever t is, you're going to square it and multiply that by negative 16. You're also going to multiply the t by 20. You're going to add those first two numbers and then add those numbers onto 6 as well to get an output. Okay. And then we'll say that Carl of y, the rule for that, I'm going to make it the square root of y plus 7 over y to the third power. So that tells us again what to do with the y. So this is the notation that we're accustomed to seeing with functions. It's got a name, it's got a variable, and a rule that tells you specifically what to do to the variable to get to the output of that function. Okay. So now let's look at what we do with that notation now that we've got it. One of the big things is evaluating functions. Okay. And the thing to remember that is that when you're evaluating a function, all it means is that if the variable in is replaced in the name of the function, then it also gets replaced in the rule of the function. Okay? So, for example, our f of x we said was 20 times x plus 8. So if it asks us what is f of 12, then that means everywhere that we saw an x in the other side, in the rule side, we're going to replace that with a 12 as well. So 20 times 12 plus 8 is equal to 248. Okay. Little math there. Okay. And this 12 that we identified right here that replaced the x, replaced this x over here as well. Okay, let's look at G. Here's my example for G. We have our name and the variable and the rule for G. but this time the variable got replaced with this whole z minus 3, and that means that every place over here that I see that variable, I also have to put a z minus 3. So it's going to be like a negative 16. I'm going to spread this out and get this in here so it's a little bit more obvious. So my z minus 3 is going where the t was, so this is now z minus 3 squared, and 20 times z minus 3, and there might be some simplification that we could do along the way there, but I'm going to leave it right here for now because simplification isn't the point of what we're doing at this point. We're just becoming familiar with our notation. Okay, and then finally we'll take a look at Carl here. Carl of negative 2 is what they want us to find. So we're going to get everything here, but another way to think about this is everywhere there's a variable, we're just going to leave an empty set of parentheses here. And the variable y got replaced with a negative 2, so everywhere we left that empty set of parentheses, we're going to put the negative 2 in there, and so we get something that looks like the square root of negative 2 plus 7 is 5 over negative 8. There may be some issues with that, but for now, this is what we would get if we evaluated Carl at negative 2.